Hey guys, we're back here. We're gonna do an exponent question. Here we're gonna the next month or so. We're gonna really hammer these questions. A lot of kids taking that April ACT. Want to make sure we see a lot of questions before we get in there in April. So we're gonna start with an exponent. Favorite topic of the ACT. Let's see what we got. X is greater than 1 and x squared is equal to a cubed. For what value of y does a to the 2y plus 1 equal x to the 6th? Alright, so let's just get right into it. We have an exponent. The first thing we always want to look at, absolutely the first thing, are the bases. And we want to ask ourselves, are the bases the same? And they are not the same. So the first order of business really is going to be to make these bases the same, right? So it's going to be difficult to change an a into an x, but ordinarily so, but at least they gave us a relationship, right? They're telling us that x squared is a cubed. Alright, so let's see, I'm just going to line them up. I like to line things up, just easier to look at it. So let's look at this thing here. So this is what they've given us here. They didn't tell us what x to the 6th was. They told us what x squared was. So let's see. I have an x squared. I got to somehow get to x to the 6th. One way to think about this is, well, what do I have to do with x squared to get it to x to the 6th? And you might say, well, geez, can't you just cube it? Sure you can, right? So if I cube that, that's just x to the 6th. Now, whatever I do to one side, I have to do the exact same thing to the other. And if I cube that, right, remember just to multiply those exponents when we raise to a power. Now I have that. So now I know x to the 6th is equal to a to the 9th. Well, let's see. They tell me x to the 6th is also equal to a to the 2y plus 1. So because this and this are the same, I can probably gather that these two things have got to be the same. Right? So I can do this. A to the 2y plus 1 is equal to a to the 9th. Now I've got the bases the same, right? And when the bases are equal, they're almost irrelevant. Essentially, once the bases are equal, then you know the exponents have to be equal. So we don't really even care about the base any longer. I can just do 2y plus 1 is 9. And then if we clean that up, right, I subtract the 1 to the other side, divide by 2, and we should get y to be 4. And that's one way you can do it. Another way you can do it here is if you're not really confident, you can try to get some numbers in there. They tell you that x is greater than 1, so you can make x equal to 2. I don't love this way, but let's just do it because I know there's a lot of people out there that like to plug and chug, so I'm just going to show it this way as well. So I know that's true. Whatever I do, I just know that has to be true. They tell me x is bigger than 1, I'm just going to make it a random one, I'm just going to make it x to be 2. Let's see where this takes us. So if x is 2, now I'm going to pop a 2 in there. So I have 2 to the 6th, which is 64, right? So that, the 64 represents this here. 64 equals a to the 2y plus 1. But you can see what the problem is here, right? Let's look at the problem. We always have to consider that relationship, right? We always have to consider that relationship. So if we're going to make x 2, 2 squared is 4, we're going to have to fit the a, so some number cubed is going to be 4, which is why really, you really don't want to do this. Could you do it? You could do it. Take your calculator out, take the cube root of 4, and that would be a. Pop that in there, put it in there. So what's the moral of the story? The moral of the story here really is you have to be able to manipulate exponents, just the basic rules, like if it's a power to a power, you have to know to multiply, and you have to try to get those bases the same. A lot of kids are going to run out of time on the ACT, and one of the reasons you're going to run out of time is because you're going to try and get numbers in there and try and do it that way. So, I'm not against that totally, but, these problems are designed to be done fairly quickly. So, make sure you know the rules, and you should be good to go.